Yes, yes. So
Yeah,
on
so
which
I,
tutorial the link is embedded? Tutorial 1 or 2?
you are, so what is happening is everybody has joined on the Google Meet. Well, you just on your video. We are speakers for today. So we will be interacting and conversing here. And the rest of us will be watching us live.
But yeah, but the video. I don't have any video because Rohit have the video. So if you want, then let me download it.
Tutorial 1 is working.
Rohit, your video is too low.
Don't worry. I'm just
It's
sharing.
fine. So just talk to me then.
I'm just sharing the video. Hello everyone. Today I am going to give my
No, my
presentation
question is
of a
on which
low
link?
power
Okay, okay.
electrically tunable higher order quadrature oscillator configuration using current differencing buffered amplifier. My name is Shekhar Suman Bora and I am from Triple IT Guwahati. So these are the main outlines of my presentation. Introduction, current mode circuits, the current differencing buffered amplifier, the proposed quadrature oscillator configuration, simulated and experimental results, application of the proposed work, a comparative study of the proposed work with earlier reported works, conclusion, and finally the references. Introduction. We know that voltage mode and the current modes are the two regulating conditions that controls the output of a power supply. So in most of the today's applications, conclusion and call for a supply to be used as a voltage mode. In voltage mode, the power supply provides the constant output voltage while providing the required current to the load.
If I have
In
any
current mode
query,
circuits, the power supply provides the constant current to the variety of load voltage conditions. What? You said something, Sudhita? So these two regulating mode works to provide the constant control of the supply. So in current mode circuits, the information is represented by the branch currents rather than the nodal voltages as that of the voltage mode circuit. So here, the current rather than the voltage is primary. So we can find the applications of the current mode circuits in the field of analog signal processing, telecommunication systems, instrumentation, etc. So this work presents a novel topology of current differencing buffer amplifier based higher order quadrature oscillator configuration. So the proposed design consumes 0.917 milliwatt power and it is proficient in performing with a minimum supply voltage of 600 millivolt. The simulations are performed using TSMC 180 nanometer CMOS process parameters. And the proposed design is also experimentally tested using commercially accessible IC 8840. Additionally, the layout is designed using the analog design environment tool of Cadence Virtuoso to confirm the workability of the proposed configuration. The current mode circuits. So the first question comes to our mind that why the shifting from voltage mode to current mode was important. So since the introduction of the integrated circuits, so the voltage mode operational amplifiers such as LM741, LM341 have been used as the basic building block for a variety of applications. But the performance requirements have been changed over the years and it was observed that voltage mode operational amplifier makes the circuit more complex whenever the low voltage, low power supply and the wide bandwidth is required at the same time. Also, the slew rate is less compared to the current mode circuits. That is, it is unsatisfactory at the higher frequencies. So, the slew rate of the current mode circuits is higher. That means it can provide the satisfactory results up to the 6 megahertz of frequency. Whereas in operational amplifier voltage mode, operational amplifier provides can provide the satisfactory results up to 1 megahertz of frequency. So the basic unit of the current mode circuits are called the current converters. The first current converter was introduced by Sir Brian Smith in 1968. There are different types and different generations of the current converters, which are like first generation current converter, second generation current converter, third generation current converter, current control current converter, multi-output current converter, etc. So other than these current converters, there are some other current mode based circuits, which are like operational trans resistance amplifier, the current differencing buffered amplifier, operational transconductance amplifier, differential difference current converter, differential voltage current converter, etc. So in the proposed work, the CDBA, the current differencing buffered amplifier is used as an active element. So the current mirror concept, so it is basically used for the implementation of the internal structure of the current differencing buffered amplifier. So the current mirror concept says that the output current should be the mirror image of the input current. So in the as shown in figure 1, where I naught is the output current and I reference is the input current. So now where we can see that the terminal D, the drain and the gate terminal is shorted. That means the VD is equal to VG. Also, so that we can write VDS, that means the drain to source voltage is equivalent into the gate to source voltage. From here we can write VDS greater than equal to VGS minus VT. So VT is nothing but the VGS, that means the minimum voltage at which the transistor starts operating. That means it is the saturation region. So after solving these equations, we can get I naught is equivalent to the I reference current other than these aspect ratios with aspect ratios. So the current differential buffer amplifier. So CDB consists of the unity gain current differential and the voltage amplifier. It consists of four terminals. P and N are the input terminals, and W and Z are the voltage and the current output terminals. So the current voltage relationship can be represented in this matrix form. From here we can see that Vp is equal to Vn is equal to 0. That means the input terminals are internally grounded. So thereby eliminating the parasitic capacitances. Also, the current flowing current at the Z terminal is equivalent to the difference between the input currents. That means the IP minus IN. Also, the VW is equivalent to VZ. That means the voltage at the terminal W is equivalent to the voltage at the terminal Z. So figure 3 represents the implementation of the CDB using MOSFETs, where the P MOSFETs are connected to VDD and N MOSFETs are connected to VSS, where this is the P terminal, this is the N terminal, this is the W, and this is the Z terminal, where IB1, IB2, IB3 and IB4 are the bias currents, and VB1 is the bias voltage. Here the current mirror concept is utilized. That means the current flowing through this terminal is equivalent to the current flow through these terminals, and this process continues. So here VDD and VSS is considered as 600 millivolt for the proposed configuration. CDBA can also be realized by using commercially accessible IC 8844 by utilizing for breadboard verification. Here two 8844 ICs have been used to get the characteristics of the current differencing buffer amplifier. So this is the proposed quadrature oscillator configuration. So quadrature oscillator circuit produces the sinusoidal outputs possessing a phase variation of the 90 degree, where the sinusoidal waveforms are taken from these two terminals V01 and V02. Here two CDBAs as an active element have been used with some passive components. So the characteristics equation of the proposed quadrature oscillator in terms of passive elements can be obtained from RC decomposition technique, which is this is the transfer function. Figure 3 represents the transfer function. Also, the frequency and the condition of oscillation are expressed in equation 4 and equation 5. By the proper selection of the CA2 and RA2, we can electronically control the frequency of oscillation. Also, by the proper selection of the C1 and R1, we can control the condition of oscillations of the proposed higher order quadrature oscillator configuration. So sensitivity analysis. So sensitivity is basically analyzed to check how the one function changes as a function of the another thing that is changing. So here the sensitivity of the passive components such as resistors and capacitors with respect to the frequency of oscillations have been calculated. It is found that the sensitivity is within unity. That means it can provide the satisfactory results. So figure 7 shows the simulated results, the transient and the steady state response of the proposed higher quadrature oscillator configuration. So this is the steady state response at the terminal V01 and V02, which provides a phase shift of 90 degree, and the frequency spectrum. The proposed structure is designed for 16.056 kilohertz, and the frequency spectrum is obtained around 69 kilohertz of frequency. And the figure 8b shows the quadrature relationship between the generated waveforms. So this is called the Lysistrata pattern. So this is basically calculated to check the phase difference between the two sinusoidal signals having the same frequency. As these two terminals have the same frequency, so this provides the Lysistrata patterns. This is the V01 terminal. This is the V02 terminal. So next is the simulated results for percentage of the total harmonic distortion, as the circuit is designed for the 68 kilohertz of frequency. So the THD is around 3.5%. So we can say that it can provide the satisfactory results up to 100 kilohertz of frequency, where the THD is below 10%. So figure 10 shows the temperature variations from 20 degrees Celsius to 100 degrees Celsius. So there are no sharp variations perceived if the temperature changes is observed. So figure 11 shows the steady state response of V01 at different process corners such as normal, slow, and fast, where you can observe that there is a slight variation of the amplitude, but there are no sharp variations are observed. So these are the experimental results. So for the breadboard verification, the proposed circuit is designed using commercially accessible IC 8844AN. So here four 8844 ICs have been utilized. So this is the terminal V01, this is the V02. So figure 13 shows the experimental steady state response of V01 and V02, and figure 14 shows the experimental frequency spectrum, which provides the frequency of oscillation is around 70 kilohertz of frequency. There is a variation of the 3% with respect to the theoretical frequency response due to the 10% tolerances of the passive components. The figure 15 shows the layout of the proposed design. The layout have been designed by using analog design environment tool of Cadence Virtuoso. So the layout consumes an effective area of around 12,400 micrometers square, and the figure 16 shows the post layout steady state response that verifies the theoretical and simulated hypothesis with respect to the layout. So the application of the proposed hybrid quadrature oscillator configuration. So an application outlook of the stated configuration is studied for the transmission and the reception of the quadrature amplitude modulation signals. So figure 17 shows the quadrature amplitude modulation for modulator and demodulator with two independent message signals such as XIT and XQ of T, which are modulated by two carrier waves with same frequency but having phase shift of 90 degree. So here the proposed quadrature oscillator have been utilized, and YIT and YQT are the detected signals at the receiver. So figure 18 shows the input signals XIT, and B shows the XQ of T. So this is the output of the transmitter. So output, the receiver in figure 20 shows that the output messages are separated by YIT and YQ of T. So it can be observed that the output is same as the input. That means it provides the verification of the proposed higher quadrature oscillator configuration. So a comparative summary of the proposed work with the earlier reported work is also studied, from where we can compare that the supply voltage and the power consumption is less compared to the earlier reported work. Also, the in earlier reported works in reference 12 and reference 14, more than two active building blocks have been realized. So in the proposed work, only two CDVS are used as an active element. So the transistor count is also less compared to the earlier reported work, other than reference 12, where 24 transistors are used, but the number of active building block is more compared to the proposed work. Also, the frequency of oscillation is less compared to the proposed work. The conclusion. So in this work, a novel low voltage, low power CMOS CDVA based fourth order quadrature oscillator configuration is presented. So there are we can summarize our contribution as here only two active building blocks are used, such as CDVA. Simulated and experimental results are performed using both CMOS and BJT based IC8844AN for the breadboard verifications respectively. So the number of most transistors are also very less. Low supply voltage and low power consumption. Also, the electronic control feature is also available. So the sensitivity and the percentage of the total harmonic distortion is also significantly less. So these are the references. Thank you.
Uh, Subrata and Jalak, you can keep talking.
So
Yeah, I
So
just
query session will be held means after the video only, no? In between, if someone has query, then
No, no, they'll be posting their queries and it will be stored in the website admin panel. After the video is
As we
finished,
discussed yesterday, right?
yeah, right.
Okay, okay. So let me comment or yes.
Have you guys posted any query on that
Yeah,
site?
yeah, yeah.
Okay, okay, let me check then.
Okay, okay. So it is saying that your query has been received. So Ishwar, can you check?
Check. Okay, wait.
I'm not able to hear him. Is he saying something?
His voice is very,
Ah,
Yeah, his voice is very low.
yeah.
you guys can continue speaking, okay, till I just post those query or something like that. Just keep talking.
So, queries that will be posted on the website will be read out by the moderator. And it will be flashing on the website. And on, I don't think all the questions will be passed even to the speaker. A few which the moderator
Yeah, few questions,
will be
selected questions will
passed.
be passed. Yeah.
Yes, correct, correct. So that way, I think that is
It's
how it's going to happen.
saying invalid username or password. Can you please check it again?
Rohit, your voice is too low.
I can hear him.
You can hear him, okay?
Yes. So yeah, Shruta, we can talk. So let's just
Ye-
You are right.
Yeah,
anything
yeah.
for that matter.
So,
So
so
the
I have
session
posted
continues.
one query. Okay. So if I have posted one query. So now Ishwar will
But
check and
the
1 minute.
login credentials are invalid. Okay, okay, now I get it. Yes, yes, yes. Yeah. So where can I find those query and questions?
Rohit, if you have access to admin panel, you'll be able to see them.
I have access to admin. Once again, user uh, VLSID team, yes. Site admin, okay. Okay.
Admin have the access to this query, right? Only.
Forms and surveys, yes.
Right.
Admin
I
access
think Ishwar can tell
your
the steps to Rohit.
profile. Yes. Okay, I have got one query from Mahima. Comment is hi, I have one query, and another is from Preet. Second question, and one more from Preet. Hi, my first question. So we are getting all the queries posted during the session. So from here I can read out the selective queries, right?
Yes.
Okay, so it is working fine for me. I think we are getting all the queries and all, and I can start playing the video again.
Selected queries will not be displayed on the screen, na?
The admin can read those queries. should I start the video again? Or you guys want to talk to each other?
You can start the video. I think
Okay.
queries are being received.
Yeah.
If everything is fine, we can just continue and see how the video is working. Or else whatever issue
Even Gaurav
arises.
sir is also watching this, so
Okay.
you speak or I can start the video.
Okay.
So the queries, so you got all the queries and you were able to check it. The video was playing fine, streaming fine. We could hear it well. Shubrata, you can hear it well and you were able to watch the video?
Yes, yes, yes. No issue from my side also.
Yeah, I got all
It's
the
fine for
queries
me too.
and I just read it out for you guys that
Yeah, please
we are
rate it.
receiving all the queries. Yeah. So I told you one from Mahima and two from Preet, and I can read all the queries. Like
All right.
Mahima commented, "Hi, I have one query," and Preet commented second question, and the first one was, "Hi, my first question." So that's how we can read out the selective queries, and we can uh, let the speaker know what are the queries and all.
Yeah,
Correct.
but I have posted one query also. You haven't received. I asked what is OTA,
No, no, Shraddha, no. I don't
but
have
I
the
have
query.
posted, and it was showing that your query has been received. Okay, let me do it again. Huh?
Okay.
Yeah, it's done. So it will take some time, I think.
I'm